In this tutorial, we're going to talk about Ohm's law. And an ohmic material is the one where the density current, the current per unit area, is going to be equal to the conductivity, which is the proportionality constant, times the electric field. So remember, the current density is directly proportional to the electric field. If we have a conductor with a difference of potential and an electric field is exerted, well, recall that the difference in voltage is going to be equal to the electric field times the length, such that the current, the density current, is going to be equal to the conductivity of this material times the difference of potential over the length. In other words, the change in potential is going to be equal to the current times area length over sigma area. This length over sigma area is going to be called the resistance. This is Ohm's law. It will state that the change in potential equals the current times the resistance. The resistance is given by the length over the conductivity times area. We can also state that the inverse of the conductivity is called the resistivity. Resistivity times length over area. So the resistance is depending on the resistivity, which is material dependent, and the geometry of the resistor. Well, we have introduced three terms now, which are they sound kind of the same, but are not the same. The first one is resistance. The resistance is the ratio of voltage to current, and it depends on the material and the geometry of the device which is generating the resistance. And the device that is generating the resistance is called a resistor. So the resistor is the device that generates or exerts the resistance. And there is a property that is dependent on the material, and this property dependent on the material is called the resistivity. So once again, resistance is given by the resistivity times length over area, that's the geometry part, and the resistivity is a property of the material. The resistivity depends on the material. Conductors have very low resistivity. It's in the order of 10 to the minus 8, and the units of this is ohm times meter, while insulators have high resistivity, which is in the order of, it could be 10 to the 3 or 10 to the even 14. Well, it depends on the conductor. 15, 10 to the 15, and this is as well ohm times meter. And the resistivity also depends on temperature. So the resistivity is going to be equal to the original resistivity, which is reported in literature, times 1 plus alpha. Alpha is as well a constant, times the difference in temperature. Usually, the temperature that is reported is 20 degrees. That's, for instance, the original temperature, so these constants, alpha, which is the temperature coefficient, and the original resistivity or the resistivity at 20 degrees Celsius is reported usually in literature. It also applies that the resistance is going to be equal to the original resistance times 1 plus alpha times the difference in temperature. And it is also very important to understand if the resistance is going to be the ratio of voltage over current, then voltage, which is measured in volts, times ampere, well, that is called ohm, and it's given with this Greek letter ohm, such that if the resistance is going to be equal to the resistivity times length over area, it is going to be, for instance, ohm times meter, which is the resistivity units, times meter, which is the length, over meter squared, and once again we get a resistance with ohm. So in this tutorial we stated Ohm's law, the resistance, resistor and resistivity difference, and how to measure the resistance given the property which is resistivity and the geometry given length and area, and well, how to take account for the resistivity, which is usually in tables, and there is a variance of temperature.